What's going on, everybody? Now we're at trend number 3, electronegativity. Electronegativity is the ability for an atom in a compound to attract shared electrons. This might sound kind of like the electron affinity stuff that we were talking about, and it has a similar kind of ring to it, but it's not talking about like the ability to, or the energy released when it gets the electron. This is the ability for it to actually get those electrons to it in the first place. Think of it like a tug of war. The higher the electronegativity is, the stronger they are in the tug of war. The stronger they are, the tighter they're going to pull in electrons. Noble gases are treated to have 0 electronegativity because they don't want to bond to anything anyway, so they're not going to be fighting over electrons if they do somehow bond to something. So electronegativity is going to increase from left to right. So as you go to the side, that means that all of the things on the right-hand side, like fluorine, chlorine, bromine, and iodine, all of those guys want to have more electrons, and those that are on the left are hoping to lose them. So the ones on the left side are like the kids in PE who are like, oh, we're going to do a tournament, and then they lose in the first round on purpose so they don't have to play anymore. If they get into a tug of war, sodium's like, okay, cool, you can have this electron, you win. I didn't want it anyway, that's fine. And the ones on the right-hand side are going to fight very competitively. Fluorine, chlorine, bromine, they are 1 electron away from being happy. They will aggressively attempt to take that electron. Electronegativity also increases from bottom to top because the nucleus becomes further away, just like we talked about before. That means they're being held less tight. The bigger something is, the harder the electrons it's going to attract are going to be for them to be able to feel that nucleus, to feel that pull from that positive charge. If something is like 4 energy levels out versus 1 energy level away, it's going to not have nearly as much of an impact on that positive charge coming from that nucleus. So, just like before, we're going to do our questions again. So, which of these has a higher electronegativity? So, again, we're going to do our point to. This electronegativity points to fluorine. So, we're going to be which one is closer to fluorine has a higher electronegativity. Hg is down here. Bi is further to the right of it. That means it's closer to fluorine, so Bi has a higher electronegativity. Phosphorus or nitrogen, phosphorus is here, nitrogen is here. Nitrogen is further up, that means nitrogen has a higher electronegativity. He or Fe, we don't even actually need to look as soon as we see He. He is a noble gas. Noble gases have 0 electronegativity. We don't count them as having any electronegativity whatsoever. And then Na or Fr, Na is right here, Fr is down here. Francium is the opposite of fluorine up here. Francium has the lowest electronegativity other than noble gases on the table, so sodium definitely has a higher electronegativity. I know that video is pretty quick. We're going to talk about electronegativity a little bit more next chapter, so I'm not feeling like I have to rush through this nearly as much. I hope that makes sense to you, though. If you have any questions, please let me know. Otherwise, this is Mr. Diamond signing off. Have a good rest of your day, everybody.